Thank you, Mark. So we're going to continue the discussion on distributed architectures and their impact on data warehousing. Edge computing, hybrid cloud data warehouses, multi-cloud systems, data-intensive applications, these are what our next guest calls the new normal of analytics. Andrew Brust is GigaOm's research director for data and analytics and ZDNet's lead blogger for big data and analytics. Andrew, it's my pleasure to welcome you to Yellow Brick Summit.
All right, thank you, Jeff. I am lead analyst at GigaOm for data infrastructure and analytics, and I focus on that same space as a blogger for ZDNet. I've actually been doing database stuff since the mid-1980s and business intelligence and analytics stuff since the late 90s. That has given me ample time to see all kinds of cycles, some of which repeat in the tech world, and now is no different. So we're going to talk about some patterns that have emerged around the data warehouse, around the cloud, and how those two come together around cloud data warehouse and distributed architectures. It's really just kind of one talk here, but it does fall into some subsections. We're going to talk about what I call the analytics new normal, some patterns around cloud adoption, the cloud data warehouse specifically. We'll talk about what edge computing is and how that ties into data warehousing and cloud data warehousing. And we'll finish up with some discussion of the distributed cloud. So this analytics new normal, if there were one thing that typified it, it's the fact that data is all over the place now. We have more applications, we have more APIs. All of these things tend to act as data sources, which means that the number of these data sources is just mushrooming. Customers are also using multiple clouds and multiple systems and platforms. And of course, systems and platforms, those are kind of vague words, but we choose those intentionally. It could mean operating systems. It could mean cloud platforms. It could mean database platforms or analytics platforms. However you choose to define it, there is, in fact, a great multitude of them used by different customers. And even if neither of these things were true, with mergers and acquisitions happening in the industry all the time, even if the two organizations individually had a perfectly consistent stable of technologies, once they come together, then obviously there's complexity added. What this means is that data is becoming more distributed, not less, and it's becoming harder to manage. I promise we're going to end on a high note here, but it's important to kind of take an inventory of the things that are stacking up as challenges so that we know how to take these challenges on. And the biggest challenge here is that even though the data is all over the place, the analytics has to be comprehensive. So you need to draw this data together in order to get a real 360-degree view of your customers, of your page views, of your price changes, of your transactions, whatever metric you are following, it needs to take all the data into account. And that means this data that's scattered everywhere needs to be gathered. The trick is, and I'm stepping on my own punchline here a little bit, but I'm doing it on purpose. The trick is that that gathering has to be done more logically than physically. Ultimately, it's a mixture, but the logical unification is going to be our key to salvation here. Now, the pandemic has had an effect on all of this as well. There has been obviously an increased shift to online commerce, for example, even in hyper-local kinds of interactions and transactions. Even if I'm ordering food from a restaurant across the street, I'm probably placing that order online and paying electronically now. So there's lots more data to track there. That has created a heightened awareness and sensitivity around the need to protect data, and it's made some data protection regulations around the world more acute. And that means that some data has to stay in the national boundaries where it was created. So even if we had a great way to pull all of our data together physically, we're actually not allowed to do that in certain cases. And so that's going to drive the need for us to have distributed architectures, because our data actually needs to stay kind of scattered in a physical sense. There's been a general acceleration of digital transformation because of the pandemic. That's been said so many times, it's almost a cliche, although it bears repetition. Data and analytics at this point has been mainstream because of the pandemic. Let's think about it, right? We're all looking at this thing and hoping for improvement. We're looking at the number of cases and hospitalizations. More recently, now we're looking at the number of vaccinations, who's been completely vaccinated, who's had at least a single dose. We're looking at data all the time. We're looking at data visualizations all the time. Flatten the curve is itself a reference to data visualization. So now the notion of analytics has become really a household notion. And when you take something from business and you move it into it becoming a household notion, then it doubles back to the business side and the demand gets at least twice as large. One more thing that's happened not in all industries, but in several, is that people have been working from home. And if we're working from home, then now we're used to the idea that the computing infrastructure is not going to be physically co-located with the team. So guess what? That's how the cloud works as well, which means we're all becoming acclimated to cloud computing, because even the corporate data center is in effect a cloud if none of us or very few of us are actually working in the corporate office. So the pandemic has been a real catalyst. Now, this brings about some things that we have to be aware of around speed and timing. There is latency that has come into things. As data becomes more physically dispersed, that means that bringing it together is going to introduce some delays. Networks can introduce their own latency as well. And again, with these data sovereignty laws, we're not even allowed to move some data, even if we had a way to do that with perfect efficiency. Analytics needs to be fast, though. So even though we have these delays, if the analytics isn't fast, we're in trouble. And that's not just about convenience, and that's not about people being impatient or picky. The whole thing about analytics is that you're not gonna drive one query. You're gonna run a query, look at the answer, and that's going to inspire you to run another and another subsequently, iteratively. That's how you get to insights, is if you keep stacking questions on top of each other. And if we don't have interactive speeds, we're not going to be able to get to those insights. So the data needs to feel like it's all in one place, even if there is physical separation. And guess what? This kind of creates a bit of a contradictory place. It feels like we're asking to do different things that are at odds. So it begs the question, what do we do? And it can create a certain amount of despair. But again, we're going to end on a high note here. So if you feel a little despair, recognize that, but also maintain some confidence that there are good answers that will get you past these quandaries. The main thing that we have to do is split with the past, where we have been looking at the siloing, the physical siloing of data as a defect, as a problem that we have to fix. I mean, it's a natural way to look at it, but we really have to embrace the idea that data wants to be scattered, right? Because data needs to be close to the operational application that creates it and that maintains it, so that we can have operational performance. We're not at the behest of analytics going to centralize all our data and then make things operationally slow. We don't want that. So we need to stop fighting this. We need to go with the grain and accept it as a pattern that is only going to grow. And again, that means we're going to have to integrate the data logically and not physically, without moving the data. Some of it will move, but we're never going to be able to move all of it and coalesce it all into a single repository. And that means we need to bring analytics to the data. It also means, though, that if our infrastructure is going to be distributed in order to accommodate these patterns in the way the data domiciles itself, that nonetheless, We're going to need a way to manage all that infrastructure in one place and have the kind of sense that it is all in one cohesive whole. So now let's talk about some trends on the cloud side. And really what we're talking about here are what kinds of organizations have been adopting the cloud. Now, as we move from the left to the right, you'll see we keep kind of going around the outside of large enterprises. So many startups were born in the cloud. They're easy. Small and medium businesses simply have less critical mass and less inertia to overcome. So a lot of them have moved to the cloud, especially because there are operational and cost efficiencies to be had from it. Within large organizations, individual business units may have moved to the cloud, especially because really individual business units often behave like small businesses. Customers with workload specific requirements where they need to spin up some infrastructure to take care of a kind of a temporary or an ephemeral workload, get their work done, and then take the infrastructure down again. That's going to be much more efficient in the cloud than it would be in the corporate data center. So that may have created a mandate for them to work in the cloud. But even though we're kind of going around the edge of this, at this point, because of many of the trends we've discussed, especially in terms of the pandemic, a growing number of enterprises and industries are now seeing the cloud, the public cloud, as quite a safe place to get their computing done and quite an acceptable place, especially as the cloud providers meet an increasing number of different certifications industry-wide for that safety. Also, pretty much anybody these days who's doing a data lake probably has that data lake in the cloud. Although the data lakes began on premises, the model, the elasticity and the cost models for cloud object storage really makes it so that the cloud is the optimal place to have a data lake. So that has also eliminated some hesitancy toward the cloud. And then if we're taking analytics new normal and the cloud together, we have to think about the cloud data warehouse. There's so many use cases for it. First of all, there are data marts, which are really kind of departmental data warehouses, if you think about it. Those work really well in the cloud. Going back to that data lake, well, you probably want your warehouse to see the data in your lake and have very ready optimal access to it. And so Lake Warehouse Federation is another catalyst for creating a cloud data warehouse. You may also have seasonal bursts in terms of how much analytics needs to be done. And so the cloud is a great place to be able to provision extra infrastructure for those seasonal bursts and then go ahead and spin it down. And that can work in a pure cloud scenario or in a hybrid scenario. Now, we've been talking about how we can't move all of the data, but some of it, the really, really important stuff, we may move. But there's more of that too. And the old way of moving that data, where we would extract it and then transform it in its shape and its metadata, and then load it into the destination data warehouse, that's not nearly so feasible as it used to be because of the volumes of the data. Now it makes more sense to extract the data, load it directly into the warehouse, and then go ahead and transform it once it's there. Cloud Data Warehouse is great for that because we can bring up additional clusters that are dedicated to the ELT, extract, load, and transform workloads. And then finally, if you want to have a close bond between your business intelligence, your data integration, and your data warehouse, the cloud is a great place to do it. So a cloud data warehouse may and typically is and increasingly is the best choice. Now, some trends in the cloud data warehouse world include some obvious ones, right? Customers are doing hybrid cloud, mixing their on-premises infrastructure with cloud infrastructure. Most customers these days, or a growing number at least, have business with multiple cloud providers, and it's container technology like Docker and Kubernetes that is making this possible, because it really takes all those different environments and it makes them look to the software mostly the same. That makes things much more agile. It makes software much more portable. In terms of my own research, well, with data warehouses, I'm only looking at them once a year, but there's a couple of interesting things there. The first time I looked at data warehouses, the title of the report was Revenge of the Data Warehouse, because it seemed like big data, a lot of the believers in big data thought warehouses were obsolete and that they were going to go away. First of all, that never happened. And second of all, the cloud changed the warehouse deployment models and cost models such that they can now take on the same volumes of data as technologies like Hadoop and Spark. So the warehouse never went away. And in fact, now it is a bona fide big data technology category of its own. And so it's come back with a vengeance, hence the name. But here's the thing, when I'm doing research around other things like business intelligence and all facets of data management, from data catalogs and data governance, all the way to data quality and master data management, all the vendors in those subcategories are looking very hard at making themselves compatible with cloud data warehouse platforms. So even when you're not looking at data warehouses, they're actually quite central, even when you're looking at other categories. We're also well past the initial days of cloud data warehousing. The first platform was Amazon's Redshift, and while that's still obviously a major player, it is not the dominant force that it was. It's got lots of competition. Speaking of competition, there's one vendor out there that was sort of the darling competitor for a while, and now even it has been around long enough where people are starting to look at it and look at their bills and are starting to get a little bit skeptical or pessimistic around that vendor, the way they did some of the old incumbent database vendors in the last couple of decades. And we talked about this one already, but it bears repetition. We need to bring analytics to the data. A couple of reasons for that. The more data you have on a given cloud, the less incentive you have to move it. It's complicated. It's also costly. There are fees for data egress, for moving data off of a cloud. So it makes much more sense in a data warehouse scenario to be able to have a multi-cloud strategy. And in addition to multiple clouds, what about this thing called the edge? So what is the edge? The edge is about doing computing in remote locations, whether that's branch offices or the factory floor or in the agricultural world, even the fields where the crops are growing. And for data warehousing, edge is still kind of a future, but we need to be prepared for it because edge data warehousing is going to be a necessity soon enough. So invest in an architecture that will allow it. And here's the thing, we need to make sure that our data warehouse on the edge and in our data center and in the various clouds where we're working is the same platform. So we can have consistency of environment as we move from position to position. The needs that are going to drive data warehousing at the edge include the fact that it's going to make a lot more sense to process the data there and then transport only the summarized data to the central data warehouse. So we're going to want to aggregate and we're going to want to filter at the edge locally. And we don't just want a generic stripped down edge database for this, right? We're going to need to do real analytics there. And so we're going to need real data warehouse platforms to run at the edge. So again, this is not a super necessity today, but it will be very soon. And you need to plan for it as you make your platform decisions. That sort of begs this question of the distributed cloud. If you take multi-cloud and hybrid cloud and the notion of edge and data center together, and data center can mean corporate data center or cloud data center. And then you also consider that in each of these environments, you may have different infrastructure. You have more control over the infrastructure in your own data center. You're going to have very commoditized infrastructure in the public clouds. And then out at the edge, you're probably going to have specialized low power hardware that may be running on a different CPU platform than you would in other places. We're going to need approaches that accommodate all this. Just as we were talking about with data being dispersed and scattered, we need to embrace that as the pattern. It's a feature, it's not a bug. So there are allies that can help you here. And the allies in your distributed cloud journey, first of all, include distributed architectures and an embrace of data virtualization, not for all of your data, but a goodly amount of it. The connectivity to it will need to be virtualized rather than relying on this idea of physically importing all of your data into the central warehouse. You'll need a unified control plane, which means you need to be able to manage all of this infrastructure, even if it's physically distributed. You want to be able to manage it just as easily if it were all physically concentrated in the same facility. Container technology and container orchestration, again, like Docker and Kubernetes, that is what makes this so feasible, because as you move between environments, the differences between those environments can be abstracted away by the container platforms. And one last thing, it's really important as we consider the future to also consider the past. The past models for data warehousing involved appliance hardware form factors. And that introduced some problems, especially in terms of expandability. But one thing that was great about the appliances was that the hardware, the storage, and the networking were highly optimized. And in hybrid scenarios where we are going to have some of our infrastructure on premises, we need to look to optimized hardware to help us out here as well. And in general, think of new patterns, but don't reject what we used to have. Rather take a strategy of cherry picking what was best about it. And optimized hardware should not be written off. So that is most of the conversation. Let's just kind of summarize and maybe put a nice little capstone on some of the stuff that we've talked about. First of all, look, big data itself was not a fad. Big data is real. It's real. Even small businesses have big data. And if they don't now, they soon will. But ditching the data warehouse, or the very premise of ditching the data warehouse to handle big data, that was a false choice, right? We shouldn't get rid of the familiarity and the power of relational platforms and SQL querying unless we absolutely have to. And we absolutely don't have to. And the cloud plus the data warehouse has made that a clear fact. Data and infrastructure are scattered by design. Let's stop thinking about this as an exception to be addressed and resolved. This is actually the pattern. As I said before, it's a feature, not a bug. So don't try and fix it, because actually it's not broken. This is the way it was meant to be. Adopt a platform that can run anywhere, any cloud, any corporate data center, and eventually make sure it's in the roadmap for that platform to run at edge locations as well. Combine your optimized and commodity infrastructure, as both have their place. We're still going to be in a world where some of the infrastructure we're going to want to manage directly, and where we have the discretion to run optimized hardware, we need to consider doing that. In general, and this is our last point, don't jump to extremes. When a new technology category emerges, and again, I've had enough time to see a lot of them, the industry just loves to jump on a bandwagon, go all in on that new category, and kind of deprecate old patterns that have worked really well as obsolete. Some of them aren't obsolete. Some of them are just classic. And ultimately, you have to look for equilibrium, for a balance between the best of the old and some of the really innovative things of the new. And that really puts it all together. Very happy to be involved in this event. Thank you very much for your attention. And I'll say goodbye right now on behalf of GigaOM and Yellow.